Hi there. We're just continuing on with Unit 8, Lesson number 2 and 3. We're going to put both the sine law and, the sine and cosine ratios into kind of one unit or one lesson. So if we look at the diagram here, you can see that we have a bunch of triangles and they're all kind of inscribed within one another. And I guess the important thing here is to note that down in this corner we have angle A, this angle here, and then we have a bunch of points B, D, F, and H, and then points along the bottom here as well, C, E, G, and J. So each sort of three-letter combination gives us a new triangle. So we can look at this triangle here at the bottom from A to B to C. So there's one triangle. Or we could look at the triangle from A to D to E and back here. And we could keep doing that. There's an additional two triangles in there we can look at. So angle A, this bottom left corner, is common to all of these triangles. The first triangle, the second triangle, the third, and so forth. So how are the other acute angles in each triangle related? It turns out that the other angles are all equal. So we'll write that in. How do I know that they're equal? Well, if I look at angle A in the bottom corner of that, maybe the first triangle here, I have angle A, and then my other angle is a 90-degree angle. So you probably remember from, I don't remember what grade it is, but we deal with three angles in a triangle always have to add to 180 degrees. So if I have angle A is the same for all of the triangles, and I have a right angle that's the same for all of the triangles, that means that third angle, the top one in the right corner, has to be the same for all of these triangles. So going back to the idea that each triangle contains 180 degrees worth of angles, and we could write each triangle contains angle A and a 90-degree angle. So they all have that in common. So we call these things similar triangles. And similar triangles are triangles with the same angles, but the length of their sides are just a bit different. So you have smaller or larger, but they're similar because their angles are all the same. So let's see if we can maybe find a bit of a pattern developing here in the diagram up above. If we're looking at the hypotenuse here, we're looking at triangle ABC to begin with. So triangle ABC is the first one here, A, B, and C. The length of the hypotenuse is 5. So I'm going to put that in my table here. The hypotenuse has a length of 5. The side opposite angle A, so if I start at A and go to the opposite side, has a length of 3. And the side adjacent A is this down at the bottom, which has a length of 4. So if I took the opposite and divided it by the hypotenuse, I would get 3 over 5. And I took the adjacent and divided it by the hypotenuse, I would end up with 4 over 5. Okay, so that's looking at just the first triangle here, this ABC. Now the next one asks for ADE. So if I started at A, and I went to D, and then I went to E, we're looking at this triangle now. So the hypotenuse is the longest side, it's going to be 5 and another 5. So the hypotenuse is going to give me 10. The side opposite angle A, so I go to the opposite, that is 6, and the adjacent is 8. If I were to take the opposite, which is 6, and divide it by 10, it would be the same thing as 3 over 5. And if I were to take the adjacent side, which was 8, and divide it by the hypotenuse, I'd get 8 over 10, which is 4 over 5. You can probably see what's going to happen here. Now, I want to point out that this triangle, these similar triangles, they aren't set up in any special way. It's not like the question was rigged so that they would all end up having the same ratio for their sides. And if you did the other two triangles, you would find that you'd end up with 3 over 5 and 3 over 5 and 4 over 5 and 4 over 5. So if you want to pause the video, put it in there and just verify that, you could go ahead and do that. Or you could take my word for it. And this isn't, like I said, this isn't just chance. This is what happens. These triangles are all similar. The ratios of their sides are the same. Just like last section, when we were dealing with a tangent, it's the opposite and the adjacent. If the ratio was the same, then we could use the tangent function on our calculator and it would just give us what that ratio was. That's the same for this. So the idea here is we're coming up with two sort of other sets of sides. So how do the ratios compare? They're all equal. And what do you think the value of each ratio depends on? That's an interesting question. And it all depends on the measure of the angle. What do I mean by that? Well, if I had a really big angle, or a really small. Let's go with a small, it's a bit easier to draw. A really small angle. You know, very low angle down here, 10, 15 degrees or so. If I had a bunch of inscribed triangles in there, similar to above, you could imagine what that looked like. If I had a really big angle, something close to 45 degrees, you can imagine what that's going to look like. So it just depends on what this angle is as to what the inscribed triangles are going to look like, those similar triangles. So maybe let's look at a couple examples. So in a right triangle, the ratios that relate to each leg to the hypotenuse depends only on the measure of the acute angle. Acute angle is that angle in the corner we're talking about, and not the size of the triangle. So we can have a really big triangle, we can have a really small triangle, but as long as that acute angle is there, we need to basically know what it is. The ratio is called the sine and the cosine. So we abbreviate sine as SIN and the cosine as COS. So with that in mind, we've kind of got all we need. If we look at a triangle that has a 90-degree angle in it, we can look at the ratios of the sides. So last lesson we talked about the opposite and the adjacent side. That was the tangent. Today we're going to talk about the other two sort of variations of sides we could deal with. So looking at this example here, this triangle, we have ABC. So if we're looking at angle A here, down in the corner, if I want to cross my triangle, this would be the opposite side. The longest side in my triangle is going to be the hypotenuse, and that leaves the adjacent, the one that forms the angle. So last day we talked about the tangent ratio. The tangent ratio is the length of the opposite angle A divided by or over the length of the adjacent. So that was tangent. That's what we talked about last day. We can also talk about the sine ratio. And it turns out the sine of angle A, or the sine ratio, is the length of the opposite. And when we're talking about the sine, we're going to divide it by the length of the hypotenuse. So the length of the opposite divided by the hypotenuse gives us the sine. And then the last, we've dealt with opposite and adjacent, opposite and hypotenuse. That leaves the cosine for the adjacent and the hypotenuse. So the length of the adjacent side to angle A divided by or over the length of the hypotenuse. So these are the three trig ratios: tangent, sine, and cosine. Those are the only three variations we can have. We can have opposite and the adjacent, opposite hypotenuse, and the adjacent and the hypotenuse. Those are the three sort of scenarios we can run into. So there's a handy little acronym we can use to remember all of these things depending on the situation we have. Each time we're given a question, it could have, any side or any angle given, and we're asked to find the additional things in that triangle. We need to know which trig function to use. So to summarize what we just wrote, the sine of A is equal to the opposite divided by the hypotenuse. The cosine of A is the adjacent side divided by the hypotenuse. And the tangent of A from last day is the opposite divided by the adjacent. So we just take the lengths of these sides and divide them. So that leaves us with our little acronym here. And you probably hear it once, twice, a couple times. It won't make sense, and then all of a sudden it'll maybe click. So if we take the sine is the opposite over the hypotenuse. So what we're going to do is come up with some letters. The sine is the opposite divided by the hypotenuse. And then the cosine is the adjacent divided by the hypotenuse. And then the tangent is the opposite divided by the adjacent, which leaves us our acronym SOHCAHTOA. We just say SOHCAHTOA. So is the sine, opposite over the hypotenuse, cosine, adjacent over the hypotenuse, and TOA is the tangent, is the opposite over the adjacent. You'll probably remember that, and it'll come in handy. So you can use a scientific calculator to determine the measure of any angle. When you know its sine, use the inverse sine. So this is kind of like when we talked about I lose the angle there. The inverse sine is when we're trying to find the angle. So we call this the inverse sine. And then if we're trying to find the angle with the opposite and the adjacent, or the adjacent and the hypotenuse, we're going to take the inverse inverse cosine. So when we're trying to find the angle, we always take the inverse function. When we're trying to find the ratio of sides, we don't use the inverse function. All right, some examples. Determine the measures of angle G and angle H to the nearest tenth of a degree. So we're given a triangle, and we're given two sides. And basically most of these trig questions will look something like this. You'll be given some information, you'll be asked to find other things. So we're given two sides, and we're asked to find the angles G and H. So the first thing I'm going to do is say, okay, I'm dealing with angle G, so I'm going to locate angle G and then measure all of my sides from angle G. So if I find angle G, it's right here. Now I need to measure my side. So the easiest one to identify is the longest side, which is always opposite, or straight across, I should say, from the 90-degree angle. So that's the hypotenuse there because it's across from the 90-degree angle. It's also the longest side of my triangle. If I started at angle G and I went straight across to the opposite side, we would end up that being the opposite. And then the side that forms the angle with the hypotenuse is the adjacent side. So what information am I given in this question? I'm given the adjacent side and I'm given the hypotenuse. Those are the only two things I know. So if I'm talking about angle G, I know the adjacent and the hypotenuse. So I think back, okay, I have the adjacent, I have the hypotenuse. Which trig function am I going to use? So if I scroll back, the adjacent and the hypotenuse, well, that's dealing with the cosine, because that is the adjacent divided by the hypotenuse. Now, some of you who are on top of it might be thinking, well, it's a 90-degree triangle, Mr. Borden. We can use the Pythagorean theorem to find that missing side, and then you can just be done with it. Well, yeah, we could find the opposite side if we wanted, but we could make a mistake finding that opposite side. And then if we were then finding the angle based on a mistake, then the angle is going to be wrong. So when we're doing these trig questions, it's important to use the information you're given instead of using information that you've calculated. Sometimes it's unavoidable. Sometimes you'll have to use calculated things to find additional things. But in this case, we don't need to do that. So if we're talking about G, it's the adjacent hypotenuse. We're going to take the cosine of angle G is going to be the adjacent side, the length of the adjacent side divided by the length of the hypotenuse. Now again, I'm trying to find angle G. I'm trying to figure out what that is. All right, so we have the cosine of angle G. Its length of the adjacent is 6, and the length of the hypotenuse is 14. And because I'm trying to find the angle G, what I'm going to do is I'm going to take the inverse cosine of 6 over 14. That's going to give me the angle. So if I were to plug in my calculator here, I can do it all in one. Inverse cos on my calculator is 6 divided by 14. So 6 divided by 14, close my bracket, and then hit equals, and I get 64.6 degrees. So that means that angle G is 64.6 degrees. On your calculator, you might have to do it in a couple steps. So you might have to go, okay, 6 divided by 14 equals, that's decimal 0.428. Then you might have to go second cosine, and then if you have an answer button, you can put it in as answer, or you can just rewrite the decimal in there and hit equals again, and you get 64.6 degrees. So just depending on how your calculator works, there's a couple different ways you might have to do that. It's important to know how your calculator works. Maybe just pick some really simple examples to go with at first, and then you can do some more complicated ones. All right, so that was the first part of the question. The second part of the question asks for angle H. So if I'm now dealing with angle H over here in blue, all of my sides have new names except for the hypotenuse. The hypotenuse is still the hypotenuse. But if I start here now and I go to the opposite side, so now the side with length 6 is my opposite. I'm dealing with a new angle. My triangle's different now. That makes this opposite side now my adjacent side because I'm dealing with a new angle. I'm dealing with angle H. So think of it, all the stuff in blue as being a bit different. So if I want to find angle H, what am I dealing with? Well, I'm dealing with the side that is opposite because I know that, and I'm dealing with the hypotenuse. So if I think of SOHCAHTOA, I have opposite and hypotenuse. Sine is equal to the opposite divided by the hypotenuse, or S-O-H, sine opposite over hypotenuse. So I'm going to take the sine of angle H is equal to the opposite side divided by the hypotenuse, the ratio between those two sides. All right. Sine of H is the opposite, in this case is 6. The hypotenuse is 14. And because I'm trying to find the angle, angle H, I'm going to take the inverse sine, because I'm finding the angle, of 6 over 14. Now, it kind of looks the same as what I had over here, but I'm dealing with a different trig function now. It's still 6 over 14, but now I'm dealing with the sine, or the inverse sine of 6 over 14. So if I jump back to my calculator, I'm going to go inverse sine, and then I'm going to put in 6 divided by 14. That's going to give me 25.4 degrees. So what have I found? Well, I found this angle H is 25.4. I found that this angle G was 64.6. And if you look at those, they should end up to 90, and they do, because 3 angles in a triangle must add to 180 degrees. So that's another little check you can do. If you found one angle, you can just go 180, subtract the other 2 to find the third angle. In this case, we used information we knew was correct, the 2 sides that were given in the question, to find the angles, G and H. All right, so that's just a random triangle type question. Now this next one is a word problem. So a water bomber flying at an altitude of 5,000 feet. The plane's radar shows it's 8,000 feet from the target site. What is the angle of elevation to the plane? All right, let's draw our plane. Here's our plane. And there we go. Beautiful plane, I know. All right, so the question says the plane is flying at an altitude of 5,000 feet. That's the plane's elevation above the ground. And then it says the plane is 8,000 feet from the target site. So here's our target over here. And you know the distance from there to there. Like that line to be a little straighter, try to make a triangle out of this, is 8,000 feet. So what I'm going to do is I'm going to take the information that I know. It's 5,000 feet, 8,000 feet above the ground, and I can just make a little triangle out of this. Words that you'll hear, angle of elevation. Now, I've put it in bold here in the lesson, angle of elevation. The angle of elevation is the angle measured from the ground up. That's called the angle of elevation. And because we don't have any letters for our triangle here, we'll just call this angle, we'll call it theta, which is just a Greek letter, usually holds the place of an angle. So what sides do we know? Well, if I started at theta, I have this 8,000 feet is the hypotenuse. That's across from the 90-degree angle. It's also the longest side in the triangle. So that's easy. If I started here and I look across or to the opposite side, this 5,000 feet is my opposite. And that leaves this blue side as my adjacent. Turns out I don't know anything about the adjacent side, nor does the question ask anything about it. So I don't really care about it. I'm not interested in it for this particular question. So if I have the opposite side here, and I have the hypotenuse, I think back to SOHCAHTOA, and the sine of angle theta is equal to the opposite divided by the hypotenuse. The sine of the angle is the opposite side divided by the hypotenuse. So those are the 2 sides I'm given. So let's take the sine of theta is equal to the opposite side, which is 5,000, and the the hypotenuse, which is 8,000. And in order to find theta, or the angle, I need to take the inverse sine, because I'm finding the angle, of 5,000 divided by 8,000. What does that equal? So again, depending on your calculator, you might have to do this one of two ways. If I take 5,000 divided by 8,000, I end up with a decimal, 0.625. So that's the ratio of those two sides. I can then go inverse sine, and my calculator has this fancy little answer button. So that takes the previously entered answer, and then I just hit equals, and I get 38.68 degrees, or 38.7 degrees. To the nearest degree the question asks, so we'll call it 39 degrees. So that's what the question was hoping for. So there you go. You're given the length of the two sides, and you can find the angle given those things because the ratio between those sides is the same. It doesn't matter how big or small the triangle is. So I guess some notes here. To solve for a missing angle, identify the angle you want to find, label the triangle from that point, or from that angle, identify which trig ratio you're going to use, so you're going to have two sides, set up your equation and solve. So those are finding missing angles. To find a missing length, you need to identify the angle you're given, label the triangle from that angle, identify the trig ratio, set up your equation and solve. Remember, if we're finding angles, we're going to have the inverse sine, or the inverse cosine, or the inverse tangent. When you're finding angles, you're always going to use the inverse function on your calculator. When you're finding a length, you're always using the cosine, the sine, and the tangent. You're given the angle. So because you're given the angle, you can put the angle in here and just plug it into your calculator. Determine the length of BC to the nearest centimeter. So BC is over here. I want to find that length. So what am I given? I'm given this angle, and I'm given this side. Those are the two pieces of information I'm given him. If I look up above here, it says to find a missing length. That's what I'm trying to do. I need to first identify the angle I'm given. So I'm given angle C. All right, step one. Step two, label the triangle from that angle. I guess it's worthwhile to put in this side as X. This is what I'm trying to find, length from B to C. And I've been given this side. I don't really care about this side. It's not part of the question and I don't need to use it, so I don't have to worry about it. So we're going to label everything from C because that is the angle we have. So if I go across from the 90-degree angle, this is the hypotenuse, and this X is the adjacent side. This is the opposite side over here, but I'm not interested in it because I'm not trying to find it and it's not given, so it's just information I don't really need. All right, so from angle C, the next thing we need to do is identify the trig ratio we're using. So in this case, I have the adjacent and the hypotenuse. So if I think of SOHCAHTOA, if I take ka, or cosine, the cosine of our angle, in this case is C, is the adjacent side divided by the hypotenuse. I'm going to set up my equation now. Angle C has a measure. It's 50 degrees. It's given in the question. So the cosine of 50 degrees is the adjacent side, which I called X, divided by the hypotenuse, which is 5.2 centimeters. All right. Now, the cosine of 50 degrees on the left side, I can just plug that into my calculator. The cosine of 50 degrees is going to be some decimal. It's a ratio between the sides. So it's 0.6427. So I could leave it as that. 0.6427 is equal to X divided by 5.2. I want to get X by itself, so I'm going to multiply both sides by 5.2. So if I jump back to my calculator, I have this ratio. Now all I need to do is multiply it by 5.2. So on my calculator, just go times 5.2, and I get 3.34. So it means that x is equal to 3.34. And in this case, we're dealing with centimeters. All right, determine the length of DE to the nearest tenth of a centimeter. DE is this side from D to E. Happens to be the longest side in my triangle, the hypotenuse. You can call it X if you want. You can call it the hypotenuse. It doesn't matter. What information are you given? So we're trying to find the length of a side. We're given an angle. In this case, we're given angle E. So I'm going to measure everything from angle E. Angle E, I go here. This is my opposite side. And EF is the adjacent, but I don't need it, so I'm not going to worry about it. Okay, I have the opposite. I have the hypotenuse. I'm trying to find, I have an angle. So, ka, toa, which one am I going to use? Well, in this case, I have the opposite and the hypotenuse. So I'm going to go for sine, because that has the two sides I need. So the sine of my angle, in this case of this angle E, is the opposite, the length of the opposite side divided by the length of the hypotenuse. So I'm going to plug in the information I know. Angle E in this question is 55 degrees. The opposite side to angle E is 6.8 centimeters, and the hypotenuse is X. Now, the last question I solved for this sine 55, figured out what the decimal was. I'm going to leave it as sine 55 until the end this time and see if I can figure out how to do it that way. So I have this X on the bottom. I want to get rid of it, so I'm going to multiply both sides by X, which is essentially going to move it from the right side to the left side. So I have X times the sine of 55 degrees is equal to 6.8. Now to get X by itself, I'm going to divide both sides by sine of 55. It's going to get rid of it on the left side. Continue up here. X is equal to 6.8 divided by the sine of 55 degrees, which is just a ratio of my sides. So my calculator, I have 6.8 divided by the sine of 55. So 8.3. So that means the length of X is 8.3 centimeters. I called it X. In the question, it was the length from D to E. All right, one more question. Determine the perimeter to the nearest tenth of a centimeter. Find all missing angle measures to the nearest degree. Okay, so basically we have two triangles here that are kind of joined with a common side down the middle. So we have the triangle up top here, and then we have the triangle down the bottom here. So we're trying to find the perimeter, so we need to know the length of this side here, the length of this side here. Once we've done that, we can just multiply it by 2 and we can go from there. It's a rectangle. So let's just deal with the blue triangle first. I have an angle down here in the bottom, 63 degrees, angle M. If I'm trying to find this side over here, this works out to be the opposite side. This is the adjacent side, and this is the hypotenuse because it's across from the 90-degree angle. So what information do I have and what am I trying to find? Well, if I'm trying to find JK here. We'll call it X if you want. You can call it opposite, or you can call it JK, it doesn't matter. But I'm trying to find that side, and I have the hypotenuse as my given piece of information along with my angle. So if I have the opposite and the hypotenuse, I'm going to use the sine of angle M is the opposite divided by the hypotenuse. In this case, this angle is 63 degrees, so sine of 63 is the opposite. I'll just write X because it's less letters than OPP. And the hypotenuse is 5.6. Now I'm trying to get X by itself. I'm going to multiply both sides by 5.6. And I end up with 5.6 times the sine, 63 degrees, is equal to X. I'm just going to plug it into my calculator. 5.6 times the sine of 63. I can plug it all in one line on my calculator, 5.6 sine 63. Your calculator might be a backwards type, so you'll have to go 63 sine, then multiplied by 5.6. Just depends on your calculator. And you end up with 4.989. So we'll just call it 5. To the nearest centimeter. Oh, it asked for the nearest tenth. So 4.989 is just going to be 5.0 anyways. So the length of side X is 5. So if this length up here now, we know it's 5. This length down here is also 5. So the only thing we need to know now is the adjacent. So if we have the adjacent, maybe we'll call it Y, and the hypotenuse. Adjacent and the hypotenuse is the cosine of angle M is the adjacent divided by the hypotenuse. So ca toa. So ca, C-A-H, cosine adjacent over hypotenuse. So we're doing the same process. Cosine of 63 degrees, that angle I was dealing with, is the adjacent side. We'll call it Y, divided by the hypotenuse, 5.6. I'll multiply both sides by 5.6, and I end up with 5.6 times the cosine, 63 degrees, is equal to Y. Plug it into my calculator. 5.6 cos 63, and then hit equals. I get 2.54. 2.5 is that Y. So that means my adjacent side, I now know, is 2.5. And this is 2.5 as well. So the original question asked me to find the length of the perimeter. So the perimeter, big P, it's going to be 2 times 5 plus 2 times 2.5, or just adding all those things up. What do I get? 10 plus 5 is 15. So the perimeter is 15 centimeters. It also asked me to find the missing angles. So if I know this guy is 63, if I take the fact that 180 degrees in a triangle minus 90 minus 63, I'm left with 27 degrees up here, which will be 27 degrees down here. This will be 63 degrees up here. You'll remember geometry rules, alternate interior angles from grade 9. If you have a Z, the insides of the Z have the same measure. Hopefully you remember that. And there you go. So that is section 8.2 and 8.3, cosine and the sine. So they're the same essentially as tangent. You just need to figure out which sides you're given and then use SOHCAHTOA to figure out which ones you need to use to solve the problem. Make sure you use the steps here in these boxes because they'll work for all of these types of problems. So there you go. One more section to do, and then that's it for this unit. Thanks.